Differential manometers are the devices which is used to determine the pressure difference between 2 points. That may be same pipe or different pipes. Suppose this is one pipeline, this is another pipeline. We are going to determine the pressure difference between these two. Now we are going to install one tube like this. This is nothing but differential manometer. The main purpose of the differential manometer is determined like this is point A, this is point B. The pressure at point A is PA, the pressure at point B is PB. The difference between or PA minus PB or PB minus PA, the difference between these two pipelines, the pressure difference between these two are determined by using the differential manometer. Differential manometers are different types, that are U-tube differential manometer and inverted differential manometer. Right? Right. U-tube differential manometer. Now, this is one pipeline. This is another pipeline. Here also having one U-tube. The tube is connected here. One end of the U-tube is connected here, and another end of the U-tube is connected here. Because of the high pressure in the pipe B, the liquid, the manometer liquid, the heavy liquid moving towards this side. This is nothing but H is the depth of heavy liquid. So this is the level, center line of the pipe to the top of the mercury level. This is H is the liquid level of pipe B. Y is the liquid level of pipe A. Right? This is where the two different the pipes are at different the points are at different levels, whereas here the 2 points are at same level. This is the U-tube differential manometer. Right? Here also the pressure is more here because of the high pressure, the liquid moving like this, the heavy liquid moving towards right side. This is H, this is X, as like as earlier case. Therefore the distance, this is equal to X plus H. This is equal to X plus H. This total distance is equal to X plus H. Right? Now we are going to determine the pressure difference between point A and point B. Now left side pressures must be equal to the right side pressures. Here the pressure at point A is PA, the pressure at point B is PB, the density of the flowing liquid in pipe A is ρ1, specific gravity is S1. The density of the flowing liquid is ρ2, density of the flowing liquid in B is S1. The density of the heavy liquid is ρ. Right? Now the left side pressures must be equal to right side pressures. What are the left side pressures? Only in case of left side, this is the liquid column. Left side pressures is equal to PA. That means above the datum line, equating the left side pressures must be equal to right side pressures. What are the left side pressures? One is PA plus another one, because of this column rho G H. This is equal to PA is the pressure at point A plus rho. What is the rho? Density of the liquid in pipe A is ρ1 into G. What is the H? H is nothing but this is X, this is H. Right? This is total depth is H plus X. Right? This is H is nothing but H plus X. This is the left side pressures. Right. Now what are the right side pressures? This is right side pressures. Right side pressures is equal to PB, that means pressure at point B, plus rho G H. Because of this liquid column one pressure, because of this liquid column another H. This is heavy liquid column, this is the liquid column of the flowing liquid in pipe B. Right? Rho, this is nothing but plus one more one, rho G H. One pressure because of pressure at point B, one pressure because of this liquid column, one pressure because of the heavy liquid column. Right here, therefore PB plus rho. What is the density of the flowing liquid in pipe B? Pipe B, that is equal to ρ2 G. What is the depth? This is liquid column depth is X, plus what is the density of the heavy liquid? Rho. This is denoted by rho G. This is nothing but H. Right. So this is the pressure at point B, and pressure because of the liquid column X, pressure because of the liquid heavy liquid column H. Now we are going to equating the left side pressures must be equal to the right side pressures. What are the left side pressures? P A plus rho 1 G H plus X, that is equal to right side pressure. So PB plus rho 2 G X plus rho G H. Therefore PA minus PB, PA minus PB is equal to rho 2 G X plus rho G H minus rho 1 G H plus X. Right. Therefore the pressure difference between pipe A and pipe B equal to rho 2 G X plus rho G H minus rho 1 G bracket begin H plus X. Density of the flowing liquid in pipe B, G is equal to acceleration due to gravity, H is the X is the liquid level in the pipe B, and rho is the density of the heavy liquid, G is acceleration due to gravity, H is the mercury level, heavy liquid level, and rho 1 is the density of the flowing liquid in pipe A, G is acceleration due to gravity, H plus X is the total depth of liquid of the column in the left side. Right? Inverted U-tube differential manometer will be used for measuring the vacuum pressure. Inverted U-tube differential manometer will have one inverted U-tube containing light liquid. That means the density or specific gravity of this manometer liquid is less than the density or the specific gravity of the flowing liquid in the B, and specific gravity of the flowing liquid in A. Right? Let us consider the inverted U-tube differential manometer is connected with two pipes. This is pipe A, this is pipe B. In two pipes as shown figure, right? These two pipes are filled with different specific gravity liquids, right? The specific gravity of the liquid, that is equal to, this is S1. The specific gravity of the liquid, this is equal to S2. The density of the liquid rho 1, the density of the liquid rho 2. That means this is different liquid, this is different liquid. So that the density is rho 1, density is rho 2. Specific gravity is S1, specific gravity is S2. Right. As displayed here in figure, point A and point B are at different levels. This is also, point A is different from point B, not at the same level. Point A and point B is also different levels. Now we are going to derive the expression for the determination of pressure difference between the 2 points. Already I have explained inverted U-tube differential manometer is used to measure the low pressure difference. Right? XX is the datum line. PA is the pressure at point A. PB is pressure at point B. The pressure difference between point A and point B, that is equal to PA minus PB. Right? This is pressure at point A. PA is the pressure at point A. PB is the pressure at point B. The pressure difference between point A and point B is PA minus PB is the pressure difference between point A and point B. H is the difference of light liquid level in the U-tube. Light liquid level. So here already I have explained, in case of U-tube, here we are going to take the light liquid. The specific gravity of the light liquid is less than the specific gravity of the flowing liquid in A and less than the specific gravity of the flowing liquid in B. Right? This is H. H is the difference of light liquid level in the U-tube. Height of liquid level in the left limb. H1 is the height of liquid level in the left limb. H1 is the height of liquid level in the left limb. H2 is the height of liquid level in the right limb. Right, rho 1 is the density of the liquid in pipe A. Rho 2 is the density of the flowing liquid in pipe B. rho L is the density of the light liquid. The density of the light liquid, that is monometer liquid, is denoted by rho L. Now here we are going to above the datum line. Here below the datum line, left side pressures must be equal to, now left side pressures must be equal to the right side pressures below the datum line XX. One is pressure at point A, that is equal to PA, and another pressure is because of the column H1, that is in the left side. And right side pressures, one is pressure PB at point B, and one more pressure that is because of the column H1, and one more pressure because of the column H. Pressure 1, pressure 2 plus pressure 3 are in the right side, pressure 1 and pressure 2 are in the left side. Right, first we are going to determine the pressures in the left side, that is PA is the pressure left side, that is the pressure at point A is PA minus, because the pressures below the datum line XX, what is the pressure because of the H1? Rho G H is the pressure. Here rho 1 is the density of the flowing liquid A, H1 is the depth of liquid in the liquid level in the left limb. Therefore this rho 1 into G into H1. Right, these are the left side pressures. What are the right side pressures? Right side pressures PB minus, because of the H2 column we have one pressure, that is pressure formula rho G H. But here the density of the flowing liquid B density is equal to rho 2, that specific gravity is S2. Right, rho 1 G, that is the depth in the right limb liquid column, is equal to H2 minus one more pressure, that is because of the H. Right, here also rho G H. This is the pressure formula rho G H. Rho in case of light liquid is denoted by rho L. Rho L into G H is nothing but H. Now these are the right side pressures, these are the left side pressures, these are the right side pressures. Now we are going to equating the left side pressures must be equal to the right side pressures. Then we have the pressure difference between the pipe A and pipe B. Right, what are the left side pressures? PA minus rho 1 G H1 is equal to PB minus this is rho 2, density of the flowing liquid in pipe B. Rho 2 G H2 minus rho L G H. Now we are going to determine the pressure difference between pipe A and pipe B. Therefore PA minus PB is equal to minus taken out rho 2 G H2 plus rho L G H minus this is plus rho 1 G H1. Right, now PA minus PB is equal to minus of rho 2 G H2 plus rho L G H1. Rho 2 is the density of the flowing liquid in pipe B. G is acceleration due to gravity. H2 is the liquid level in the right limb. Rho L is the density of the light liquid. G is acceleration due to gravity. H is the liquid level, light liquid level in the right limb. Right, rho 1 is the density of the flowing liquid in pipe A. G is acceleration due to gravity. H1 is the liquid level in the left limb. Therefore PA minus PB is equal to minus of bracket begin rho 2 G H2 plus rho L G H1 plus rho 1 G H1. This is the formula for the determination of the pressure difference between the two pipes. Right, this is formula, same, both are same. PA minus P2 is equal to, this is the formula. Right, single column manometer is the modified form of the U-tube manometer. Here only a tank is provided in left limb as compared with the U-tube manometer. A large cross-sectional area reservoir is provided here. The cross-sectional area of this reservoir is 100 times the cross-sectional area of the pipe. That is only the difference. Right here, so because of the pipe connected, the left end connected to the pipe A, so that the liquid level, the mercury level in the large reservoir, that is reduced by very small, but the rise of mercury level in the limb is too high. Right here also we are going to determine the pressure at point A, that is denoted by P. Pressure at point A. Here also, what are the pressures in the left side? What are the pressures in the left side limb? What are the pressures in the right side limb? This is the left side limb. This is the right side limb. What are the pressures? One pressure, that is because of the water column H1. This is the one pressure in the left side, and one more pressure because of the pressure at point B. Two pressures in the left side. Right side pressures, one is because of this this is DH, that is very small variation, and another pressure because of the H2. Right? Vertical single column manometer, inclined single column manometer, both are same. Only in case of inclined single column manometer, in case of vertical single column manometer, the H is taken as directly. The mercury level in the right limb is taken as directly. This is H2. Whereas in case of inclined single column manometer, this is equal to this is H2. This is H2. This is L. This is theta. Only we are going to determine H2 here as compared with the single column manometer. Here sin theta equal to opposite side H2 divided by hypotenuse is L. Therefore, H2 is equal to L sin theta. This is the only difference as compared with the vertical single column manometer. In case of vertical single column on getting the directly value H2, but here H2 is equal to L sin theta. Right? This is section XX before connecting the pipe at point A. L is the length of heavy liquid moved in the inclined limb XX. This is L. And H1 is the height of lower specific gravity liquid. H1 is this is height of lower specific gravity liquid. This is lower specific gravity liquid, high specific gravity liquid. H2 is the height of heavy specific gravity liquid. This is H2, height of heavy specific gravity liquid. Here in case of inclined single column manometer, H2 is equal to L sin theta. Already I have explained. Delta H is the fall of heavy liquid in the reservoir. Delta H, this is the delta H because of the pipe connecting at point A, the change of depth in the reservoir is delta H. The reservoir is delta H. Right? Now we are going to derive the expression for the determination of pressure at point A. S1 is the specific gravity of the light liquid. Rho 1 is the density of the light liquid. S2 is the specific gravity of the heavy liquid. Rho 2 is the density of the heavy liquid. Right? S1 is the specific gravity of the light liquid. S2 is the specific gravity of the heavy liquid. And Rho 1 is the density of the light liquid. Rho 2 is the density of the heavy liquid. And YY is the datum line after connecting the manometer with container. After connecting the manometer, this is the datum line. After connecting the manometer, this is the datum line YY. Now the left side pressures must be equal to the right side pressures. Right? What are the left side pressures? Left side pressures. What are the left side pressure? One is PA, that is the pressure at point A, plus, and also the liquid column is the after connecting the pipe, that is moving at a distance of delta H. So this is liquid column, this is also liquid column. Right, from this point to this point is H1, this is delta H. Therefore, what is the standard formula pressure? Rho G H. Right, left side pressure is equal to pressure at point A plus pressure because of this column plus this column. Right here, that is equal to PA, pressure at point A, plus rho is nothing but rho 1. The density of the flowing liquid is rho 1. G is equal to G. H is nothing but H1 plus delta H. H is nothing but H1 plus delta H. This is the liquid level. H1 plus delta H. Here H1 plus delta H. These are the left side pressures. PA plus rho 1 G H1 plus delta H is the left side pressures. Then right side pressures. What are the right side pressures? Right side pressures is equal to, this is DH delta H, mercury level delta H. This is H2 is the another level. Therefore, right side pressures is equal to rho G H. This is the pressure formula, pressure WH or rho GH. This rho is nothing but rho 2 density of the heavy liquid rho 2. G is nothing but G into H is nothing but what? Delta H. Delta H plus H2. Delta H plus H2 plus delta H. These are the right side pressures. Right side pressure is rho 2 G H2 plus delta H. Now we are going to equating the left side pressures must be equal to right side pressures. Right? P plus rho 1 G H1 plus delta H is equal to rho 2 G H2 plus delta H. Right. Now this is equal to P plus rho 1 G H1 plus rho 1 G delta H is equal to rho 2 G H2 plus rho 2 D delta H. Okay. Therefore, P is equal to, pressure at point A is equal to rho 2 G H2 plus rho 2 G delta H minus rho 1 G H1 minus rho 1 G delta H. Right? P is equal to, here we have delta H. Here is also we have delta H, so that is equal to delta H taken out, rho 2 G minus rho 1 G plus rho 2 G H2 minus rho 1 G H1. Rho 1 G H1. This is the formula. Therefore, pressure at point A is equal to delta rho 2 G minus rho 1 G plus rho 2 G H2 minus rho 1 G H1. But here the value delta will be quite small, and therefore this may be neglected. Therefore, this entire term is neglected. Delta H is neglected, automatically this entire term is neglected. Therefore, pressure P is equal to, pressure at point P is equal to P2 G H2 minus finally pressure P is equal to, pressure at point A is equal to rho 2 G H2 minus rho 1 G H1. This is the formula for the determination of pressure at point A in case of single column inclined manometer. Single column inclined manometer. Right, this is the formula, rho 2 G H2 minus rho 1 G H1. Right, because delta H is very small, this is neglected automatically, this entire term is neglected. Therefore, P is equal to rho 2 G H2 minus rho 1 G H1. But this equation is applicable in case of vertical single column manometer. But here H2 is, already I have told you, I have given H2 is equal to L sin theta. In place of H2, we are going to take L sin theta. Right? Are you clear? Therefore, P is equal to, what is the formula we have finally? Because delta H is very small, this entire term is neglected. Delta H is very small, this entire term is neglected. Therefore, P is equal to, P, pressure at point A is equal to rho 2 G H2 minus rho 1 g h1, but h2 is equal to L sin theta. Therefore this is equal to rho 2 g h2. In place of h2 we are going to take L sin theta minus rho 1 g h1, right? This formula is applicable in case of vertical single column manometer. In case of inclined single column manometer, h2 is equal to L sin theta. Therefore in case of inclined single column manometer, L sin theta rho 2g minus rho 1g h1. This is the formula used for the determination of pressure at point A in case of inclined single column manometer. In case of vertical single column manometer, this is the formula rho 2g h2 minus rho 1g h1. In case of vertical single column manometer, in case of inclined single column manometer, L sin theta rho 2g minus rho 1g h1. Right? Thank you one and all.